The colonization of Mars has been on everyone's lips for years. But what if the red planet isn't actually the most suitable celestial body for our foray into space? Basically, Mars is a radioactive desert. Its atmosphere is so thin that cosmic radiation would have grilled you in a matter of months. In the long term, there would probably be no way around moving to underground bases and burrowing like a mole. But then there's Saturn's moon Titan. It has gigantic lakes of methane and ethane, hydrocarbons that could be used as real rocket fuel with oxygen. The atmosphere of this satellite is so dense that theoretically you could strap on wings and glide through the air like a superhero. Sure, at around minus 180 degrees Celsius, Titan is almost as cold as liquid nitrogen, but at least we wouldn't be in danger of slowly being roasted by radiation. So, at the end of the day, would it make more sense to abandon our ambitious plan for Mars and set off for Saturn's largest moon instead? Stay tuned until the end and find out with us. When it comes to pure distance, the answer is clear. While a trip to Mars would only take 6 to 9 months, it would take about 4 to 7 years to reach Titan. Nevertheless, the second largest moon in the solar system could turn out to be the celestial body that allows us to build a permanent civilization far away from Earth. To understand why this is the case, we first need to uncover the true face of Mars. In principle, a journey time of 6 to 9 months does not seem unrealistic, but that changes abruptly when we realize that it's essentially a one-way ticket to a cosmic radiation hell. The truth is that the red planet lost its magnetic field and atmosphere billions of years ago. As a result, Mars is defenseless against high-energy particle bombardment from space, and that would have dramatic consequences for any Martians. Astronauts on the International Space Station, which is still protected by the Earth's magnetic field, already receive 100 to 200 times the radiation we experience on the ground. But on Mars, the radiation exposure would be up to 3 times higher. The solution to the problem would therefore be to retreat below the surface to shield ourselves from dangerous cosmic radiation. To put it bluntly, we would have to spend billions of dollars and risk the health of the crew just to live like primitive cave dwellers on another planet. The Martian settlers would see daylight about as often as a miner in the 19th century. But what exactly is the situation with the Martian atmosphere, or rather what is left of it? Well, the natural protective shell of our neighboring planet is about 100 times thinner than that of Earth. It would be like trying to breathe at an altitude of 30,000 m. In comparison, even the air at the summit of Mount Everest is thick enough to cut. Apart from the fact that we couldn't breathe the Martian air anyway, it gets even worse. The Martian soil also contains toxic chemicals called perchlorates, which are not only harmful to humans, but also highly reactive and can even explode under certain conditions. Attempting to grow food here would be like gardening in a chemical laboratory's waste storage facility. Is Titan the better Mars? But what about Titan? Is Saturn's colossal moon really the ultimate cosmic El Dorado? Well, to find out, we should first address the frosty elephant in the room. Titan is not just cold, it's freezing cold. Specifically, the average surface temperature is minus 79 degrees Celsius, significantly lower than anything Earth has ever experienced. The bottom line is that it is so cold here that water becomes harder than granite. And unsurprisingly, the rocks on Titan's surface actually made of frozen water ice. But how can it be that the moon's exterior is adorned with gigantic lakes and even seas? Well, quite simply, these are not bodies of water in the traditional sense, but rather huge accumulations of liquid methane and ethane. So, we're dealing here with hydrocarbons, which are used on Earth in combination with liquid oxygen as fuel. The largest of all methane lakes is called Kraken Mare and covers an area of about 400,000 kilometers. That's bigger than the Caspian Sea. In other words, Titan offers a potentially huge natural gas station for future space missions, provided the necessary oxidizer is available. In this way, the liquid methane and ethane deposits could secure the energy supply of a human civilization for thousands of years. But the real game changer is the atmosphere of the celestial body. With about 1.5 times the air pressure of Earth, it is dense enough to offer some protection from cosmic radiation. You could say that Titan was a kind of natural spacesuit that envelops the entire moon. And this is where it gets really exciting. Combined with low gravity, which is only about 14% of Earth's gravity, the dense atmosphere creates conditions in which we could theoretically fly. No joke. With wings on their arms, humans could glide through the air here almost like birds. But even aside from all the Icarus dreams, Titan has the edge in some respects. Due to the sparse atmosphere, every machine on Mars would have to be built to be radiation resistant, making it heavier, more expensive, and more complex. Solar panels lose efficiency more quickly. Electronics fail more often, and the astronauts' living quarters have to be built under thick protective layers of Martian rock. On Titan, however, the dense atmosphere allows for gentler landings of spacecraft and landing vehicles and places significantly less strain on technology and infrastructure. What on Mars are still anxious minutes during which a billion-dollar mission can quickly turn into an expensive crater could theoretically be accomplished on Titan with nothing more than parachutes. But the construction possibilities on Saturn's largest moon are also impressive. Thanks to the low gravity, structures could be built here that would be unimaginable on Earth or Mars. These include kilometer-high towers, bridges spanning entire regions, and cities floating the atmosphere in the best in style. Titan also offers real advantages in terms of energy supply. The dense atmosphere allows for the efficient use of wind power, as the strong winds provide a continuous supply of energy. In addition, it might be possible to use a flow of methane streams and lakes to generate mechanical or electrical energy. Those who want to rely on nuclear energy could also do so on Titan. And thanks to the dense atmosphere, astronauts would also be protected from cosmic radiation. The radiation from the reactor itself would of course still have to be shielded, but overall the risk to the crew would be lower than on Mars. The risk of the unknown. So far, Titan may sound like the prime example of an alien celestial body that is ripe for colonization in the future. However, the whole truth is that a trip there would not be a relaxing journey in the traditional sense, but rather a mission fraught with considerable challenges. Due to the extreme cold, all living spaces would have to be heavily insulated and heated to make survival possible. The atmosphere consists mainly of nitrogen and methane, but contains no oxygen. So, all habitats would have to be airtight and have their own oxygen supply. And while the low gravity would make even the most daring engineering dreams come true, for us Earthlings, it would have long-term consequences that we simply cannot foresee at this point. It is well known that astronauts lose bone density and muscle mass in zero gravity. However, how this would affect Titan's gravity over generations is another matter entirely. We do not know how low gravity would affect bones, muscles, the cardiovascular system, and the development of children in the long term. And as mentioned at the beginning, the distance should not be underestimated. The celestial body is over 1.2 billion kilometers away from us. The journey to Titan would take 4 to 7 years, and transporting materials and people would be correspondingly expensive, and time-consuming and energy care will be practically impossible. In addition, Titan is by no means a paradise. Due to large pressure differences, toxic surface chemistry, and weather phenomena such as methane rain or storms, all technical systems would have to meet enormous requirements. The same applies, of course, to energy supply, food production, and infrastructure development. All of this would go far beyond anything we have ever achieved on Earth, let alone on another celestial body. But if, and this is the exciting part, we ultimately succeed in overcoming all these adversities, Titan could reward us with a splashing gift. Beneath the moon's kilometer-thick ice crust lies what is likely an ocean of liquid water, possibly containing more water than all of Earth's oceans combined. Despite the extreme cold, the cool liquid remains liquid because heat from the interior and dissolved salts prevent it from freezing. Measurements from the Cassini mission and analyses of the moon's rotational behavior strongly suggest that water is sloshing around underground on Titan. The question of all questions now is whether we could even reach the water on Titan. After all, it's likely to be located up to 100 kilometers below the surface. Consequently, the idea of conventional mining or drilling techniques quickly fizzles out. Instead, thermal drilling could be used to penetrate the ice. Alternatively, melting robots or cryobots could be used to work their way down to the ocean. And who knows, maybe they will even find the original inhabitants of Titan there. It cannot be ruled out that microbial life already exists there. According to this, There could be extremely resilient microorganisms in the depths of the moon that survive in the darkness and cold thanks to chemical energy and tidal heat. Whether we would really be the first living beings on Titan is therefore uncertain, but the same applies to the question of whether the satellite will ultimately succeed in overtaking Mars and becoming humanity's first home away from Earth. Far away from our video, the subscribe button is already waiting to become the home of your clicks.